Hello guys, and welcome back to another episode of chemistry. And of course, we have started discussing benzene and its compounds. And we said that benzene and their compounds or the derivatives, okay, are all called what? Arenes. Are all called arenes. Okay, that means that benzene is the simplest arene. Okay, is the simplest what? Arene present or available. Okay, so we have benzene and all other arenes are derived from what? Benzene itself. Okay, so benzene and its compounds, they are all called what? Arenes. Please take note of that. If I was an examiner, right, and I want to dash you, okay, a question, all right, I want you to don't have free mark. It's the kind of question I can ask you. Which of the following is the simplest arene? Okay, and I'll put benzene among the options. I may put phenol, I may put benzaldehyde, I may put benzamide, okay, as the options, and then you are at liberty to choose. Okay, so please keep that in mind. They are all called arenes, that is benzene and their derivatives. That is what benzene and its derivatives. Okay, it's what we're going to be looking at today. We're going to see a lot of the derivatives of benzene, okay, and all together they are called arenes. So now please note that this video tutorial is brought to you by the O3 School Jamb CBT practice app. And there's a reason why it is named after that, because this app enables you to practice and study. All right, everything is in one app. We'll talk about the app in a moment. Let us see a question from the application. This is a past Jamb question. It's a 2007 question. Number 3, okay, it says it is being displayed on the screen right now. It says that which of the following represent an aromatic compound? Okay, remember that benzene and all their derivatives are all aromatic, isn't it? They are not aliphatic, like the alkenes, alkenes, and the alkynes. Okay, so please take note of that. So which of the following represent an aromatic compound? A says C₆H₆OH, C₆H₆C, C₆H₆D, C₆H₆OH. At the end of the class, you already know the answer to this question, but we'll come back to this question at the end of the class and not before, because we want to give you value first before you start answering questions. You must understand why something is something before you try attacking it. So please listen to the class and do not go nowhere. At the end of the class, we'll answer that question and many more from this wonderful application. All right, so please, like I said, this tutorial is brought to you by O3 School Jamb app, and it asks all the past questions, so you don't need to worry about past questions at all. What's more is that there's a lecture note that is structured according to the Jamb syllabus. Many of you do not read according to the Jamb syllabus, and I shake my head for you. So please, you need to get the app. And what's more is that it's a question search feature. So after you have studied benzene, you can go to the question search feature, type select chemistry as subject, and then type benzene. All the questions that Jamb has set under benzene will come out for you to answer. Therefore, you fortify yourself concerning anything that has to do with benzene. Another important thing, of course, is the UTME mock challenge. That is the best feature of the app, because this app is the UTME challenge or competition is a competition we organize for all students that are writing Jamb for a particular year. You compete with your mates, win a lot of amazing prizes, but those are not the important part. The important part is that you get used to what Jamb past question, and also you see your result released every Saturday, because that challenge is held every Saturday. So you do not want to meet any of the challenge. Go to Play Store immediately, download the application, pay the activation fee, just a little token, all right, to show that what you are serious. So please activate it and start practicing your way to success. So let us see benzene and its compounds. Okay, so the first benzene and its derivatives rather. So let's see the first derivatives of benzene. The first set we are going to be considering, we'll call this one monosubstituted. Okay, let me put a space here. Substituted benzene. Okay, so the first set we're going to consider are called monosubstituted benzene. That means we're going to have a benzene ring, and then we have one group, okay, attaching itself to that benzene ring. That's why it's called mono. One group attaching itself to a benzene ring. Okay, let us see some cute examples. It's very easy, so please open your mind. So we have we're going to be using the resonance hybrid form of benzene. Remember, we said that benzene, we have resonance forms. In the last class, we talked about this, right? Okay, we have resonance forms, resonance forms. All right, this is this bond, double bond here, double bond here. Okay, then we now have this. Okay, we could put the double bond here. Instead of here, we could start from somewhere here, then leave this, have a single bond, put another bond here, have a single bond, put another bond here. These are resonance forms. So call these ones the resonance forms. Okay, they will now have the resonance with hybrid. Instead of doing this or this, okay, we'll just do something like this, okay? Okay, as what? Representing what? Benzene ring. This one is called resonance hybrid. Okay, so if that is clear, this is what we're going to be using throughout what this naming. Okay, so please put your mind down and open your heart to listen. Okay, so the first example we're going to be looking, of course, is having a benzene ring, and then we have what, because we're discussing monosubstituted benzene now, we're going to have what, one group attaching itself to a benzene ring. All right, so for example, if you have a benzene ring like this, okay, all right, benzene ring, then we'll now have a nitro group. Okay, this group is called nitro group. Nitro what group? Okay, if I have a nitro group that is attaching itself to a benzene ring, what do we call this type of what compound? Okay, so this will now be what now? It become nitrobenzene. We'll now call this one nitrobenzene. It's very simple. Okay, so this is nitrobenzene because we have what, a nitro group attaching itself to a benzene ring. But I can remember that this group can be here, it can be here, you can put it here, you can put it here. When we have a nitro group attaching itself to a benzene ring, we call it what? A nitrobenzene. Now let us see another example. Let's say it is not what, a nitro group that is attaching itself, and let's say it is an OH group, an hydroxyl group. Okay, let's say it is an OH group that is attaching itself to this benzene ring. Okay, so if you have what, a benzene ring like this, and then we have an OH group attaching itself to this benzene ring, what we call this benzene type compound is called phenol. We call it what? Phenol. So please take note of that. All right, so that C₆H₆OH, all right, that we're seeing during what the introduction to this class as a past question is actually what? Phenol. All right, so if you have what, an hydroxyl group or an OH group attaching itself to a benzene ring, we call it what? Phenol. So now let us continue. So we have what? Phenol. What about if it is not an OH group? Let's say, for example, it is a methoxy group that is attaching itself to this benzene ring. Okay, if you have a methoxy group, C₆H₆, it's a methoxy group. If I have a methoxy group attaching itself to a benzene ring, it's still a monosubstituted benzene. So because of that, we call this benzene type compound, we call it anisole. So the parent name for this was benzene type compound is called what? Anisole. When we have what? A methoxy group attaching itself to a benzene ring, we call it what? Anisole. All right. So what about if it is not a methoxy group? Methoxy, methoxy. METHOZXY, methoxy group. All right. So what about if it's not a methoxy group? Let's say it is an NH2 group. Okay. If it's an NH2 group attaching itself to a benzene ring, for example, an NH2 group attaching itself to a benzene ring, this one we'll call it what? Aniline. All right. We'll call this one aniline. All right. If you have a benzene ring, then we'll now have an NH2 group attaching itself to that benzene ring. We call it what? Aniline. I hope it's getting very clearer. So what about if it's not an NH2 group? Let's say it's a carboxylic acid group. Okay. For example, if you have that's why if you followed us when we talked about homologous series, okay, this become very easy for you. All right. So you must know all your functional groups. So for example, let's say it is now a carboxylic acid. All right. Double to O, then OH. Or we can draw this compound like this. Okay, like this. All right. Then of course, don't not forget your O. Like this, your O0 or O in the center. Okay. So if, let's say for example, instead of writing this like this, we can write it like this: COOH. All right. So if you have what? A carboxylic acid group attaching itself to a benzene ring, we call this one a benzoic acid. Benzoic acid. All right. So please, you must take note of that. Having what? A benzene ring, and then we now have what? A carboxylic acid group attaching itself to that benzene ring. Okay. We call this one what? A benzoic acid. What if it's not a carboxylic acid group? Let's say it's an aldehyde functional group. Okay. Let's say it's an aldehyde functional group. That is CHO. Okay. If I have a CHO attaching itself to a benzene ring like this. What do we call this? We call this one a benzaldehyde. Benzaldehyde. Okay, because this is what? The aldehyde functional group. Okay, so if we have what? An aldehyde functional group attaching itself to a benzene ring, we call it what? Benzaldehyde. Benzaldehyde. I'll go over it again. I have a benzene ring, aldehyde functional group, we call this what? A benzaldehyde. What if it is not what? An aldehyde functional group? Let's say, for example, it is just a double bond that is attaching itself to this benzene ring. Okay, it's a double bond that is attaching itself to this benzene ring. Okay, just like we have this, all right, it's a benzene ring. You now have like this, just a double bond attaching itself to this benzene ring. All right, we call this one a styrene. Styrene, all right, a benzene ring, and of course a double bond attaching itself to the benzene ring is called what? A styrene. It's as simple as ABC. All right, so please take note of that. So I've seen phenol, I've seen benzaldehyde, I've seen benzoic acid and the likes. I've seen this one now having what? Just two double bond attaching itself to the benzene ring itself. You call that what? Simply call that what? A styrene. So now let's say, for example, it is not what? A double bond that is attaching itself, but let's say, for example, a ketone functional group. A ketone functional group. A ketone functional group. Okay, we have something like this. Then I have what? C₆H₆. Okay, let's say a ketone functional group is attaching itself. All right, sorry, not this. Okay, we actually have something like this. The body to what? To O. All right, bond to oxygen. Okay, if I have a ketone functional group attaching itself to a benzene ring, this one is what? Is the ketone. Okay, or we'll call it the acetyl group. Okay, we call it the acetyl group. Okay, if you have a ketone functional group attaching itself to a benzene ring, what we call that one is acetophenone. We call it acetophenone. All right, we call it what? An acetophenone. All right, so please you must take note of what? Of all these functional groups, but take note of all these names. Okay, so now that is acetophenone. But what if it is not what? A ketone functional group? Peradventure, let's say it is an halogene that is attaching itself to this benzene ring. An halogene that's attaching itself to this benzene ring. Let's say, for example, is chlorine that's attaching itself to this benzene ring. What do we call this one? We simply call this what? Chlorobenzene. All right, it's as simple as that. But let's say it is not chlorine. Let's say it is even now bromine. What do we call that one? We call this one bromobenzene. All right, it's as simple as that. But let's say, for example, it is not an halogene. Okay, let's say it's an alkyl group. For example, like ethyl. Okay, let's say an ethyl is attaching itself to a benzene ring. Okay, if an ethyl, let's say if ethyl is attaching itself to a benzene ring, let me say I'm going to have C₆, C₆. Okay, or I can just simply say C₂H₆. C₂H₆, which is what? The ethyl group. If it's attaching itself to the benzene, what do you call that? We call that what? Ethyl benzene. We call this one ethyl benzene. But what if it is not what? An alkyl group like ethyl? Let's say it is not methyl. If it's methyl what? Group that's attaching itself to this benzene ring. Okay, a methyl functional group. Sorry, methyl group, not a functional group. Now, sorry, a methyl group of what? C₆. Okay, if C₆ is attaching itself to a benzene ring like this, we call it what? Toluene. We call it toluene. Although you could still say methyl benzene, but it has a name. Okay, so it has a parent name. When a methyl group, not ethyl, when a methyl group is attaching itself to a what? To a benzene ring, we call that what? A toluene. All right, so this you must take note of all this. So what if what? An imide functional group, imide. Okay, if an imide functional group is attaching itself to what? To a benzene ring. All right, so like this, you have what? O, then you have what? NH2. Okay, if an imide functional group is attaching itself to a benzene ring, what do we call that? We call that what? A benzamide. Okay, benzamide. Okay, benzamide. Simple as ABC. But what if it's a nitrile group? When we're doing homologous series, okay, we talked about the nitrile group. Obviously, what is a nitrile group that's attaching itself rather to a benzene ring? Okay, so I'm going to have C, so we brought it to N. Okay, this is called what now? This is called benzonitrile. Benzonitrile. All right. So if it's what? A nitrile group C triple bonded to N that's attaching itself to this benzene ring, we call it what? We call it what? A benzonitrile. We call it a benzonitrile. Now, very importantly, let's make this a little bit tricky. What if we have what? A CH2 group? Then we now follow it up, okay, with, for example, let's say an halogen. Okay, let's see. We have what? Let's say a CH2 group. So this is a benzene ring. Then we now have what? A CH2 group. This will be CH2. If this C is here, it will be what? HH. All right. So if it's a CH2 group attaching itself to benzene, then we now have again, let's say a what? An halogen attaching itself also. Okay. So this is what? Yes, C. There's what? This is a stick form. Okay. That means there's what? There's a carbon atom here. Okay. So that carbon atom will have 2 hydrogen atoms. All right. So this one is called what now? It's benzyl bromide. Okay, if it's chlorine, we'll call it what? Benzyl chloride. Okay, it's as simple as A, B, C. Now, why do we call it benzyl chloride? Now, a benzene ring having 6 carbon atoms, okay, is called phenyl. We call it what? Phenyl. Okay, but once we are having an extra carbon atom, making it 7, all right, as you can see the attachment, making it now 7 carbon atoms plus the 6 that was there before. Benzene is C₆H₆. And B is a C₆H₆, but there's an extra carbon here making it 6,7 now. So that one is not now called phenyl again. We now call it what? Benzyl. That's why we call this benzyl bromide or benzyl chloride, depending on the what? The halogen, okay, or the other group that's what? Attaching itself to the benzene ring. Is that clear? All right. So now let us continue. Let's say we have what? An isopropyl group attaching itself to a benzene ring. Isopropyl group. Many of you do not know isopropyl group. Okay. Okay. Let me just quickly talk about that group. All right. Let's say we have what? A stick form like this. All right. This is 1, 2, 3, 4, 5, 6, which is what? An hexane. All right. And then let's say we now have here a group. All right, we have here a group going like this, going like this. Okay, so this is actually an isopropyl group, this group here, because at this point there's a carbon atom, at this point there's a carbon atom, at this point there's a carbon atom. But the problem here is that what? This branch, this substituent that is here, okay, you can see it is what? It is branched. It does not continue. It's different. This group is different from this one. Okay, it's different from having something like this. Okay, now coming like this. And let's say now going up again like this. Okay, for this kind of case, you know that here is C, here is C, here is C. And of course, this will now be what? A propyl group or a propyl group, as you may call it. Okay, but in this case, you can see the branching off. All right, it goes up, then it branches into 2. This kind of group is what we call iso group. It's an iso group, or call it what? In this case now, because it's having 3 carbon, we call it isopropyl group. Please understand that. Understand that once and for all right? Even in your university, the same thing will still be taught. Okay, so please get it once and for all. Okay, should I go over it again? Yes, let me go over that again. So because it is not branched, all right, we have a name for it. We call it what? The iso group. Okay, you call it iso group. It is not what? Continuous. It is branched rather. It is branched. It is not continuous. We call it what? An iso group. That's how we call this isopropyl group. How many carbon atoms does it have? 3 carbon atoms. Okay, let's say you now have another one like this. Okay, like this. All right, 1, 2, 3, 4. Now having 4 carbon atoms. 1, 2, 3, 4. This will be what? Normally it's supposed to be what? Butyl. Okay. All right, but because it is branched, it is called what? Isobutyl. So if we have an isopropyl group attaching itself to a benzene ring, all right, what do we call that one? We call it what? Isopropyl benzene. We call it isopropyl benzene, but it has a parent name. Okay, so we have what? This. Then I have this attaching itself to a benzene like this. We call this what? Isopropyl benzene. Okay, sorry, benzene. All right, and it has a name which is called cumene. Please take note of that. It is called cumene. All right, isopropyl benzene, same thing as what? As cumene. It has a parent name. Okay, let's say what if it is not an isopropyl group? Let's say it's an what? Isobutyl group. Let's now added this one to it now. So this one is called what? Either isobutyl benzene or call it what? Tet-butyl benzene. Okay, tet-butyl benzene. This tet, okay, 4, okay, showing that what? There are 4 carbon atoms tet-butyl what benzene. Okay, tet-butyl benzene. Okay, so that is how name them. If you have an isopropyl group, okay, we call it isopropyl benzene. If you have an isobutyl group, we call it tet-butyl benzene. All right, now let us now go to let's say I'm talking about monosubstituted benzene. I have just one group attaching itself to the benzene ring. Let's now talk about what disubstituted benzene. Okay, disubstituted benzene derivatives. All right, now this is mono, change it to di. All right, di. Okay, so for example, let's say we have a benzene ring. All right, and then it attaching itself to, let's say, 2-methyl group C₆H₆, C₆H₆. All right, so remember, a benzene ring attaching itself to 1-methyl group is called a toluene. All right, now we're having 2-methyl group attaching itself to a benzene ring. So we can number, here is 1, here is 2, carbon 1, carbon 2. Okay, so this can simply or easily be called 1,2-dimethyl benzene. All right, but it has a name. Once you have 2-methyl, if you have 1-methyl group attaching itself to a benzene ring, we call that one toluene. All right, but if we have 2-methyl group attaching itself to a benzene ring, we call that one xylene. Okay, please take note of that. So this is what is xylene. Okay, we can also call this group, this structure orthoxylene. And the reason why we can call this orthoxylene is because when we have 2 groups attaching itself to a benzene ring and they are in position 1 and 2, we call it ortho. All right, so if they are in position 1 and 2, if the 2 groups are in position 1 and 2, we call it ortho. If they are in position 1 and 2, we say it is ortho. That's how I can say this one is orthoxylene. All right, or if they are in position 1 and position 3, we call that meta. We call that one meta, M-E-T-A. If they are in position 1 and 4, we call that one para. Okay, right there, come the para for me. All right, so that is 1-4. 1-4 is para, 1-2 is ortho, 1-3 is meta. Know this and know it once and for all. All right, so please understand why we say this is also called orthoxylene. Okay, so now let us say this group, they are not actually in position 1 and 2. Let's say they are actually in position 1 and 3. Okay, so this will now be 2. This, let's say here you now have this C₆ here now. This is position 1 and 3. Okay, so if this is in position 1 and 3, what will we call it? That will be 1, this is 3, is 1, 3 dimethyl benzene. Okay, and because you know that a benzene ring having 2-methyl group is called It's called xylene. Then of course you can call this one now. You can call this one what now? 1, 3 xylene, which is what? 1. If the groups are in 1 and 3, they are called what now? Meta. You can easily call this one meta-xylene. It's as simple as ABC. I hope that is clear. All right. So if you have 2 groups attaching itself to benzene, they are in position 1 and 2, we say it is ortho. If they are in position 1 and 3, we say it's meta. If they are in position 1 and 4, we say it's what? Is para. Okay, so now for example, let us have let us continue with this structure. Let's say now we have a methyl group somewhere here. Let's say we have a methyl group here, C₆, and then let's say here we have a bromine group, okay, attaching itself to the benzene ring. We're talking about disubstituted. So let me take this one off. So if you have a structure like this, a benzene ring attaching itself to what? So a methyl group and a bromine group. What do we call this? So this obviously will be position 1. This will be position 2. But we know that we know that a benzene ring that is attaching itself to a methyl group has a parent name. The parent name of a benzene ring attaching itself to a what? To a methyl group is called what? It's called what? Toluene. It's called toluene. All right, so we'll call it toluene. So because it is toluene, all right, that means that what? This position 2 will be what now? 2-bromo. All right, we can now call this compound now 2-bromo toluene. All right, we can call it 2-bromo toluene, or we can say because they're in position 1 and 2, the 2 groups are in position 1 and 2, we can call it what? Ortho-bromo. Okay, ortho-bromo toluene. I hope you understand the progression. Okay, so the parent name for a benzene ring that has a methyl group attached to it is toluene. Okay, but the bromine group is in position 2. That's why we have 2-bromo toluene. Okay, now thirdly, the groups are in position 1 and 2, which is auto. That's why I call it auto-bromotoluene. Should be clear? Very, very clear. So now let us look at what another one. Okay, let's say we now have what here. Let's say we have what an aldehyde functional group. All right, let's say we have an aldehyde functional group somewhere here. Let's say here we have an aldehyde functional group CHO, and then here let's say we now have what chlorine. All right, CHO and what and chlorine. All right, so now let us go the same what idea that we used to what in talking about the last question, okay, or the last example rather, will be the same idea we used here. The parent name for a compound that for a benzene that attaches itself to what? To an aldehyde functional group. We call that one what? A benzaldehyde. Okay, a benzaldehyde. This is the parent name. Parent name is benzaldehyde. Okay, so now it asks what a chlorine in what? In what position? This is position 1, this is position 2, this is position 3. On the what? On position what? Position 3. Now this compound will actually be called what? 3-chlorobenzaldehyde. Okay, and of course this is position 1 and 3. So this can easily be called what now? Meta-chlorobenzaldehyde. To show that the aldehyde functional group is in position 1, okay, while the other group, which are clearly seen, is what is in position 3. All right, so it's as simple as A, B, C. What about if we have, let's say, a methoxy group, and then we now have what a nitro group attached to a benzene ring? A methoxy group OCH3, and then a nitro group NO2 attaching itself to a benzene ring. Let us see what we call that. All right, so let's say here in this in this position, let's take this off. Let's say in this position we have what now? Here OCH3. Okay, simple. Then here, for example, this position 2. Let's say position 2 we have what? NO2. Okay, so what I'm going to call this, or let me just take this off. Let me just say position 4. All right, this is 1, this is 2, this is 3, this is 4. Let's say we have our NO2 here. This is a nitro group, this is what? A methoxy group. All right, and of course, when a methoxy group is attaching itself to a benzene ring, the parent name of this structure is what? Is anisole. Abi? Okay, because go back to the beginning of the video where we talked about what a methoxy group attaching itself to a benzene ring. We call it what? Anisole. So the parent name is what? Anisole. Okay, so the parent name is anisole. Then of course we have what? The nitro group on the fourth carbon. Okay, so that would be what now? 4-nitro what? Anisole. Okay, because this is what? Anisole. Because they are in position 1 and 4, we can easily say what now? Para-nitro what? Anisole. It's as simple as A, B, C. Okay, so please let us take note of that. The position matters. Okay, where they are 1 and 2, 1 and 3, 1 and 4, they all what matter. That's why we call this what? Para-nitro-anisole or 4-nitro-anisole. Now, let us continue. Let us now talk about. Let's say we have 3 groups attaching itself to the benzene ring. Okay, let us see some examples under this. 3 groups attaching itself to benzene we call tri-substituted benzene. So we'll call this ones tri-substituted benzene. Let me take this off. Tri-substituted benzene. So here now we're going to have what? Tri-substituted benzene. Okay, so now we have 3 groups attaching itself to the benzene ring. Let's take some example. Let's say we have something like this, a benzene ring. Let me draw it out for space. A benzene ring like this. All right. Okay, I have a benzene ring. Sorry, way how long this one now is. Okay, so we have a benzene ring like this. We have what? This to show the resonance hybrid. Then let's say at this position we have what? An OH group. Let's say at this position 2, we have what? An NO2 group. At this other position 3, let's say you have what? Another NO2 group. Or let me just shift this one downward. Let me put this here, NO2 group. So these are what? 3 what groups attaching itself to a benzene ring. Okay, so you see the same method we're using to talk about, to name what the disubstituted benzenes that we're going to also use to talk about these tri-substituted benzenes. Now, the Parent name for a benzene ring having an OH group attached is called what? Phenol. We know that one is what is called phenol. So because of that, as simple as ABC, we can number 1, 2, 3, 4. That means we have what? A nitro group on position 2 and position 4. So this can be easily called 2, 4 dinitrophenol. Simple as ABC. 2, 4 dinitrophenol. So as simple as that. Nothing more. Now, let us take another example to drive our point home. Let's say now here we have 3 other different groups. So here, let's say here is bromine. Then of course, let's say here, yes, okay, carboxylic acid group, OH. Then let's say here is a nitro group. So having 3 different groups attaching itself to a benzene ring. So remember, I can put COOH here. Now, what do you call this? The parent name for this compound will be what? Will be what? Benzoic acid, because it's the benzene ring has a carboxylic acid group attaching itself to it. So parent name will be benzoic acid. Okay, so the benzoic acid is the parent name of this compound. Then now the other groups, what position are they in? This is what? Position 1, this is position 2, position 3, position 4, position 5. Okay, and bromo comes before nitro. So I'm going to have what now? 5 bromo. On what position is bromine in? 5 bromo, comma. All right, then I'm going to have how many what now? Nitro, 2 nitro. Right, you know you use hyphen, 2 nitro. And then what? You now have what? Benzoic acid. Okay, which is the parent name. So the name of this compound will be what? 5-bromo, 2-nitro-benzoic acid. All right, so now let us see the final example and we are done. Let's say we have 3 different groups that do not have a parent name. Okay, let's say we have 3 different groups without what? A parent name. Like let's say we have an halogen, we have a nitro group, and then another halogen. Okay, so if you have something like that, let's say here we have what? Let's say bromine. Then here, let's say we have NO2, and then here, let's say we have what? Chlorine. All right, so what do we now call this compound? All of them, there's none of the group that attach here that has a parent name with benzene. Okay, so this one is called nitrobenzene, this one is called bromobenzene, this one is called chlorobenzene. All right, all of them carry the name of their group. Okay, so that means that what? The solution to this is to find the shortest what? Link or route. All right, let us see. If you have what? If you start from here is 1, here is 2, here is 3, here is 4. On what position are the groups on? This bromine group is on position 1, nitro group is on position 3, chlorine group is on position 4. Okay, so if you number like this from this top to the bottom, all right, I'm going to have what's this position. So if you number from the bottom to the top, here will be 1, here will be 2, here will be 3, here will be 4. Okay, so yeah, I'm going to have what? Position 1 for chlorine, position 2 for NO2, position 4 for what? For bromine. All right. So for that singular reason that this is a shorter what link. Okay. This has what shorter what numbers. This is what I'm going to what this numbering is what I'm going to what adopt for this naming. So as usual, bromine will come first before chlorine before nitro. So I'm going to have what now? 4 bromo. Okay. Then I'm going to have what? 1 chloro. Okay. And then what? 2 nitro, what now? Nitro benzene. It's as simple as ABC. So this is how what we name what benzene and what and their derivatives. Very, very quite easy and interesting too also. So if you know them once and for all and you enjoy, because I'm going to, even in your university, you are going to need them. All right. So well, the video will always be here. So in case you need it in future time, can come back and what and still follow your commander, your grand commander to what to study. So let us see that the question we started with, the 2022 question, or is it 2022 question number 19? Okay, no, it's a 2007 question number 3. It said, which of the following represent an aromatic compound? Okay, and of course, as you can see here, we have what? C₆H₆OH. We say D is the answer. There is the correct answer because that will what? Be phenol. Okay, C₆H₆OH. All right, so phenol has what? OH group attached to what? To a benzene ring. C₆H₆is no longer That one, that is no longer benzene. Okay, so please take note of that. Now then, please make sure you will go to Play Store, download the application, like this video, subscribe to this channel, and of course keep sharing this video to your friends and loved ones. Let them learn and what and pass. Download the app and what and activate. It's for your own good. All right. In the next class, we'll start talking about the preparations of benzene and the reactions of benzene and the uses of benzene, and we're done with benzene. Thank you for watching.